Hello, everybody. I am Mini Mr. Pflaumer, your host, and welcome to episode 2 of Crash Course Physics. In today's episode, we're going to be focusing on dynamics, specifically balanced and unbalanced forces.
Ta-da! Hello everybody. Let's start off with something simple. First, you need to know that there are four main types of forces: tension, gravitational, normal, and frictional. As you can see, there's an apple moving on this table. The apple is moving left at a constant speed. The hand is pushing the apple. It may not seem like it, but there are multiple forces acting on this apple right now. As you can see on this free body diagram of the apple, there are four forces acting on this apple. In the downward direction, Fg, or gravity on the apple by the earth, is forcing this apple down on the table. However, the table is also pushing up on the apple with the same amount of normal force as the earth's gravity is pushing down, because the object is moving at a constant speed. The hand is pushing on the apple, which is the normal force to the left. There's an equal frictional force going right on the apple. We know this because of Newton's first law, which states that an object moving at a constant speed will continue to do so unless acted upon by an unbalanced force. The formula for the y-plane would be the sum of the forces on the y-axis is equal to mass times acceleration. So in this case, it would be the sum of the forces on the y-axis is equal to Fg on apple by earth minus Fn on apple by table, which is equal to mass times acceleration, which is equal to 0 because there is no acceleration. As the acceleration is 0, this formula and rules also applies to all constantly moving objects in any situation. Because of Newton's first law, since the object is moving constantly, the sum of the forces in the x direction also adds up to 0. So it would be Fn on apple by hand minus the frictional force on the apple by the surface is equal to 0. Now that you understand basic balanced forces, let's move on to something more complicated: unbalanced forces. Imagine now that the apple is being pushed by the hand and is accelerating at a constantly increasing velocity of 15 meters per second per second. Its mass is 20 kilograms, and the frictional force between it and the surface is 50 newtons. Now, remember that because we'll use it later. Now, the horizontal forces are Fn on apple by hand minus Ff on apple by surface, which is the same as before because we have the same situation except that it's accelerating. And now this is equal to mass times acceleration, but it's not equal to 0 since acceleration is not 0. Now, Fx, the horizontal forces, is equal to 20 kilograms times 15 meters per second squared, because this is ma. M is the 20 kilograms, and A is the 15 meters per second squared. And this is equal to 300 newtons just because of math. Now, Fn on apple by hand is minus Ff on apple by surface is equal to 300 newtons because we know that the horizontal forces is the net force. And this is equal to 300 newtons. Now, we are given that the frictional force is 50 newtons, and we can plug that into the equation, and therefore we can solve for the last variable, which is Fn on apple by hand, and we get 350 newtons. Because 350 minus 550 is 300. Who would have guessed? Now, the horizontal forces on the apple are, vertical forces on the apple are Fg on apple by earth plus Fn on apple by surface. This is equal to mass times acceleration, which is still 0 since the object is not accelerating upwards or downwards. Now, we are given another equation, Fg equals mass times gravity. This is the equation for figuring out how much gravitational force is on an object based on the planet it's on, which is the gravitational force, which we can get the gravitational force on. Now, we know that on Earth the gravitational force is 10 meters per second squared, and the mass of the object is still 20 kilograms, and therefore Fg equals 200 newtons. From this, we can also figure out Fn on apple by surface, which is 200 newtons since it's at a constant speed, and which I didn't mention before, we also know both Fn and Ff. So just from this information now, we know all the forces on the apple. newtons, and we know that 350 newtons is equal to the Fn on apple by hand because it's the last part in the equation, and we can solve since it's the last variable in the equation. Now, why didn't you finish this, Nick? Why?